All right, ladies and gentlemen, we need to finish up section 8.6, which is graphing quadratics. Just for a quick review, let's go ahead and get started. Take a look at our screen. So if you remember, all quadratics come from this basic guy, no matter what it is. So that's all degree 2 people, all come from the basic guy x squared. Okay, he's like the grandfather of grandfathers of quadratics. So please make sure that you know that he always looks horseshoe shaped, no matter what, and going through the origin is the beginning. Okay, so it all starts there, origin, right? And now we mentioned 2 words from last time, which is the vertex and the axis of symmetry. The vertex, again, is those peaks or valleys that occur in the tops or bottoms of these curves. And then the axis of symmetry is that line you could draw that if you sliced one of your graphs, you could fold it over onto the other one. And you would not be able to see an overlap. Okay, so that's why it's called symmetry. It's symmetrical. If you sliced it, it'll fold over perfectly. All right, so we learned that. Now, that means if we know how to find the vertex, we have the vertex, and then we can have the axis of symmetry, right? Then we know what the vertex is, right? And we can find other cool things. So let's talk about what makes the graph move around, because it's not always centered at 0 like the regular x squared is. Like these guys are moving. Each one of them moves somewhere. Okay, so let's take a look at that now. All right, and I'm gonna try. I kind of pre-wrote some things just to make it easier, and we're gonna enable one of the best programs I think ever invented, and that was Desmos graphing. It makes it very easy to see things that happen. Okay, so I just want to go in. I want to focus on each one of these. Okay, so the first place I want to focus in at is what happens when, okay, we start with the basic guy, which is f of x equals x squared, and we start playing with that coefficient, this thing that is, oops, that's a clearly on this thing that's a, okay? We start playing with that, right? What happens when it's a big number, when it's a small number, when it's a negative number? And then we start to find things out, okay? So let's do that exploration ourselves, okay? So let's go to Desmos, and I had some stuff pre-typed in here, but I think we'll start this from scratch, okay? So if we look at this, okay, here is regular old x squared. He is the guy that's in red. All right, now let's put a number on him. And this is what I'm going to do. I'm going to make a positive number, and we'll just do a comparison of positive and negatives. What do positives do? What do negatives do? Let's make it a 100x to the second power. Well, it seems like it got skinnier, but hold on. Remember, the question was positives or negatives. So I'm going to do the same thing, because I don't have an equal comparison to say what happens when it got negative. So negative 100x to the x. That doesn't work out. X squared. Oh, it's the same looking graph, except now it's flipped upside down. So hold on. So are we thinking that negative numbers flip things upside down? Well, let's see here. That means if it was a negative x squared, it would look exactly like the regular x squared, except it should be turned upside down. Well, let's see, are we right? So we are right. So bottom line is what we come to figure out is that if it's a positive, right? A positive would be the guys that are the first two, the red one or the blue one. Okay, if the coefficient is positive, it must open upward. Boom. If the coefficient's negative, it must open downward. Alrighty. So what does that mean? So let's go back to our sheet and take a look at it. Okay, so that means, and that's a big thing you need to know, that if that a value, the number in the front there, is positive, i.e. positive, that is going to open upward, and then if it's less than 0, it's going to open downward, okay? And remember, the whole point of this is that if we know what certain things control the x squared function, then we don't have to constantly plot points. Plotting points is a disaster. I hope you guys know this. We want to just be able to just keep going through and through, and the entire process, and as we go through that process, we want to make sure that we can do it for everything, right? So this is really cool to know that if it's a negative in front, it's going to turn upside down. It's pretty cool. All right, so let's do something else. So what if, okay, so the function here, what makes it a quadratic is this degree 2, the square here, right? So what mathematicians do, and which makes them very weird and also very interesting, because they look at things in such a broad spectrum kind of way, and with a microscope out at the same time, well, they're like, well, this is a function. It takes in x's. So what if we added a number to the x before it got squared? And then what if we added a number to it after it got squared? So I'll give you an example of what that would look like. So for decimals, and what we're asking here is what if it looked like this? What if we started putting a number plus the x, and then you add that together first, and then you square it? Like, what would happen? What does that control? Okay, well, let's take a look-see here. Okay, I'm going to use the same kind of guys. I'm not going to bother with the negatives or positives, and we're just going to compare it to what we normally compare it to. Okay, so here's a normal x squared graph. We're always going to compare to him. And the question is if I were to add or subtract, and we're going to do both because we want to get a good comparison, x squared minus, say, 2. Oh, I used a 2. How about a 3? Well, 2 moved it to the right 2 units, it looks like. Yeah, it did. I wonder if we make this a positive 3, what would happen? Oh, a positive 2 moved it to the left, though. Interesting phenomenon. Normally when we add things, we think they're going to go in the positive direction, which would be to the right. But it did not do that. It went in the other direction, which was to the left. Let's check this one more time. So what I'm thinking is that if I make this a minus 3, it will go 3 units, but it won't go in a negative direction. It's going to go in a positive direction. I bet it'll end up at the third spot on the right, on the positive side. So let's make this a minus 3. Bingo. Okay, so bottom line is, what did we just figure out? That the 3 that is being subtracted from that x, it is moving each one of those values a little bit to the right. Okay, and likewise, if you added 3, it would go to the left, so the opposite direction. So what do you need to know? Okay, so bottom line, this is a key here. Okay, if I can do this without breaking anything. I have a big finger. Oh my God, I'm always touching stuff. All right, so bottom line is, if that k value, okay, if that thing is positive, okay, shift it not in the positive direction, which would be to the right. We're going to go to the left this time. So if you think about the x-y axis, normally if we see if we're adding a positive number to the x, you would think we would shift it in a positive direction. Absolutely not. We're shifting it into the negative direction. So what are we saying here? That if this thing was, say, f of x equals x minus 5 squared, this minus 5 would definitely tell me that it's going 5 units. 5 units to the, which way, right or left? You better have said right, because it's going to do the opposite of whatever's here. Minus 5, it should do 5 units in the positive direction. Plus 5. Okay? And likewise, if it was a plus 5, it would do 5 units in the negative direction. Okay? So, cool mnemonics to think about. All right. So, bottom line is now we understand that if we add stuff to it, and again, maybe I'll caution you one more time. Let's caution you. I'm always good for cautioning people, so I'll put them in this nice little think bubble to caution you. Careful. This one is opposites. Is opposites. Okay? Because remember, we're adding 4. It doesn't mean we're going to the right 4 on the x-axis. It'll be to the left. Okay, so be careful. All right, finally. What happens when we actually add an h on the outside? Okay, so some of you already saw my notes there, so let me do my presentation. It'll look very cute. Okay, so here we go. What happens? I'm going to leave some stuff in here. Let's do another one. X, say, plus 4, comma, raised to the second power. So it should shift me 4 to the left. We confirmed, just like we did before. Adding 4 made us go 4 units to the left from the origin. Okay, but let's see what happens here. I'm going to take the same guy. I want to duplicate him. If it lets me. There it goes. All right. If I were to, say, add 3 to this one. Oh, it actually moved it up 3. You guys see that? Moved it up 3. And likewise, if I take away, say, 1, anybody know what's going to happen to the guy? Yeah, you're absolutely right. The vertex dropped down 1. So bottom line is, now we've learned, is that number, the 3 here, or the -1, it's exactly what we say it is. Every point needs to shift down 1 unit. So the vertex that was originally right here moved down to -1. And the vertex that was at -4 plus 3, it moved up to 3. Okay? Pretty simple. Okay? So this one's not opposite. This one's exactly how you think it is. Plus 3, go up 3. minus 1, go down 1, right? So that's something we need to make note of. So let's make note, and I'll draw some pictures around it just to make sure we're good. Okay, so bottom line is, if that H is positive, shift it upwards. Boom, done. If it's negative, shift it downwards. It's really that simple. All right, so now what I want to do quickly is I'm going to show you why knowing these details helps your life so much, okay? So again, let's do this. Just as a reminder, that A value, if it's negative, it opens downward. If it's positive, it opens upward. Cool. This K value, this is the guy that's opposite Z. Okay, so be careful. If it's a +7, you're going to be moving 7 units for sure, but it ain't going to be in the positive X direction. It'll be in the negative one. Okay, and likewise, if it was a -5, you wouldn't be moving 5 units in a negative direction. You'd be moving 5 units in the positive direction. Okay, so be very careful. So this is the superiority of this. Okay. Let's say, I don't know what happened here, but this is the problem I wanted to do, that this is the problem. Okay, and it just said graph, okay, and now in the final exam it does say graph, okay. When you graph this, well, what happens? Well, this is what I know. Check this out. I know from looking at this that the basic graph, which looks like this, okay, that it has to flip upside down because of that negative. Okay, so because of this negative, it's got to flip upside down, okay. This is going to shift it 1 unit to in the opposite direction. So +1, I'm only going -1. So it's going to maybe shift it 1 unit to the left. Okay. And then finally go up 7. Now this is a lot to do in one graph. So I would not recommend anyone doing it this way. So what I'm going to do is I'm going to draw each graph out. And that's what you should do when you want to show your work. Because if you notice, as I started writing one graph on top of the other, it started to get more complicated. Remember, the work is about building confidence for you. Build your confidence by showing the work the way you want to be shown. Okay, so I'm just going to start with a basic graph. Here's x squared. Boom, right at the origin. Done. Okay, we're just going to track everything. Okay, that -2, that's the next guy I'm going to draw. Okay, so we're always going to take care of that coefficient first. And all I'm going to do is I'm going to draw it upside down. I'm not going to draw it any wider or any skinnier. Why? Because I don't have a scaling factor. I don't have hash marks or anything to compare it to. So as long as I know it's opening downward, that's good enough. Okay, the negative is really what we want to focus on. Okay, now, the next thing we're going to do is I want to focus on is that negative is the +1 that is on the inside. It's a square. Sorry, guys. I'm getting ahead of myself. I'm like, we're getting ready to write the next thing. I want to change the colors, and I can't change the colors because my computer is not moving as fast as I want it to move. All right, so now the +1. Now, what does the +1 do? Again, this shifts 1 unit left. Okay, so what does that mean? Our graph, which looks like the guy on the right, boom, 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 is going to shift 1 unit left. So now it's going to be right here. So instead of being at 0, 0, now it's at -1, 0. Okay, just want to let you know that's what actually occurred here. Now, will you always have all these? No. Sometimes you'll have them, sometimes you won't. Okay, so if you don't have a left-right shift, you won't have a number there. It'll just be blank, right? So it's always something to take heed of. Okay, and then finally, well, what do we do when we want to add that 7? Okay, and this is the order you want to stick into until you get to 1800 and you get the whole entire show and the whole barrage of functions. Then you'll have a new method of transforming things. But for right now, this is good enough. Okay, so this is this, boom, 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 boom. And finally, I want to add 7 at the end. Now, this is the one that we figured out, of course, that if we're adding 7, there's no tricks to this one. Adding 7 means go up 7. Subtracting 2 means go down 2. But that's on the outside, right? So this is go up 7 units. Okay, so that means the graph that is red now will turn into this graph, which is blue. If I can get my colors. I wish they would make a color palette thing for this. This would be awesome. So go up 7. So 1, 1, 2, 3, 4, 5, 6, 7. Put a little dot there, and then it comes down. It's really that simple, okay? And here you go. We won't always just say graph. We'll say graph labeling your vertex, and now you can do that. 7. See? And check this out. Isn't that cool? You can kind of see where your vertex came from. So if you know what it is in this form, we could have just started from the beginning and just pulled out the vertex and said, oh, it's the opposite of that and that. Why? Because I'm shifting it opposite in that direction and going up in that direction. Done. Okay, so vertex, and then they always tell you to label, and I don't know if they tell you to draw it, but I'm going to draw it anyway, the axis of symmetry, which is whatever the heck that has to be. So I can have the axis of symmetry just by looking at this again. It's the opposite of that, so it's got to be the vertical line going through the vertex, which is a vertical line, x equals a number, whatever the x value in the vertex is, it's got to be the equation. Done. Okay, so very, very easy to do. Okay, so we are now 15 minutes in. I don't want to take it any further because I want to go into the next pieces. And the next piece should be a quick one. That's how to find the x and y intercepts, but it's going to take me more than a couple minutes. So, all right, guys. So what I want you to do, definitely take notes on this, okay? When we come back, we'll learn how to find the x, y intercepts, okay? So let us know if you have any questions. Again, office hours are always available to you. And we're just at the drop of a dime. All right, guys. See you on the next video. Bye.